It's always always good to have a short break, because this leads to new ideas. And if you think it would be an idea, we propose a worldwide test of my idea with walking 300 meter north-south and east-west, and getting the difference in degrees, or arc minutes or arc seconds rather, on a GPS receiver. The problem is that the people don't understand how it is. And now, as you talked about Joss Lace, he was the guy who wrote me a comment on my second video I made, which he didn't understand that it was meant ironically. And but his advice was perfect. He said I should make it shorter. And then I communicated with him back, and then he understood that it really was not proving a flat Earth, but how the title suggested, but rather vice versa. And maybe we should contact him, whether he would make a nice graphic about the difference, which shows how this longitude and latitude system
could work out. Yeah,
it will be the same on all. And we make a project of 3. Have you ever had direct contact with him?
No, not yet. Only in my chats.
Yeah, okay. Because he was the second one who commented, and I also, of course, subscribe to his channel, and I usually leave a comment when he makes a new video, which is, I think, not more than every 3 months or so. I think he makes a video.
Yeah, but I have used many of him already. Yeah. He is also. Okay. He says, "Use whatever you want." Yeah.
What is I did quite.
He always says that you may use whatever you want from the videos he makes.
Yeah, but if he especially contributes a part which clearly shows the idea, and we do in our own vicinity at the matching streets do an experiment which don't dox us too much where we exactly live, and with the initial data, and suggest that others should send us the data where they live, and everybody can look this up in Google Maps. And if someone has grossly measurements that are very much deviate from what the cosine should be, everybody can go and remeasure this. When you say where you did take this measurement, it's a little bit similar that what Sparkane did.
Yeah, no, correct. What we could do, we could start ourselves just to do one test. I take a street here. Yeah,
that's exactly my idea.
And I give you the figures.
One test. It works for us probably. It works quite well from 500 meters, I think. The more north you go, of course, the lesser is the difference. I think I calculated once that north of the 60th degree or so, you would have to walk a kilometer or so. But I was very, I know that GPS is much better than I assumed. I assumed 3 meter or 5 meter exact.
How accurate do you think they can be at the moment?
Yeah.
What do you think?
I noted I had a GPS handheld even before the how was it called? Somewhat with selectivity or so.
Yeah.
They varied the times probably in the satellites depending on the area, so that you got in 95. I think it was 10 meters or so typically. It depended on how much satellites were visible.
Yeah.
And then it went down to 2 meters, 3 meters. And then, of course, before this, how was this called? How was that feature or this misfeature called, which was activated before 2002? Not selectivity, but
I don't know the name, but it was introduced, or it was already in there by the Americans because they didn't want other nations to use it in the most accurate form.
Yeah, but it became more and more useless because it was the same for a larger area of, say, 100 by 100 kilometers.
Yeah.
And there were fixed receivers which sent on FM frequency the current misdirection. And then you had differential GPS receivers, which was, of course, much more expensive than the typical handheld ones, but in airplanes or so. And a differential GPS could calculate this back based based. I see you know.
Yeah, we used in the Netherlands a lighthouse for that. So the location of a lighthouse. So when the lighthouse was moving 5 meters to the east, then you knew you had to correct for 5 meters back.
Yeah, and this deviation was even sent on radio on a certain frequency, and then my first GPS device were 700 German marks, but I found it interesting to have it, and I had no maps and nothing in this. I still have that old Garmin, but the satellite IDs were hard-coded there, and it does not work any longer because the satellites are longer.
Now, what I have seen here with a guy who, for the city, measures your house, the lot. If you buy a house, then they always come. The kadaster, it's called in the Netherlands. They come and check and redraw your lot so that you exactly know where your borders are. That guy had a device that took the American, the European, and the Russian GPS, and he was accurate within 2 centimeters.
I think when the device is guaranteed to be in rest, they can also do, I think, phase measurements, which gives additional accuracy.
Yeah, but he showed me he was holding it still, and he had a certain the coordinates in centimeters or something, and he just like he lifted it a little bit and then put it down again, and it was less than a centimeter, but let's say 2 centimeters, and 1 digit changed in the display. Mm-hmm. So it was immense accurate.
Yeah, the main point, of course, which I don't doubt that it is, but the main point in this situation is not only that the last digit moves, but if you move away 10 meters and move to exactly the same point, that it comes back to exactly the same measurement.
Yeah, of course.
Because
one thing is sure, you can't do this with towers.
Yeah. Okay, a nice excursion on GPS. Did I send you? Yes, I sent you the from the guy who explained how GPS works to the other one who played dump. Did I send you these things?
I'm not sure. You did send me one where the guy was doing this. How do you call it? He jumped on teachers and suddenly started to ask questions about vacuum. And how vacuum...
A vacuum?
Yeah.
No, I think this wasn't the thing. I remember I sent it to you when you painted your room.
Oh, okay. Then I haven't opened that one, I guess.
Yeah, if you open it. The first hour is not so interesting, and jump ahead 1 hour. I sent you the time spent.
Yeah.
The time stamp again. There are 2 parts in it where they talk about GPS. And it's how is it called? How is this guy called?
Wasn't that the McToon then?
Name Multi-Tom-Tom.
Oh, okay. Yeah.
And but it's not on his channel. And he had a Christmas 2 or 3 years ago. He had a talk with on Geostreber's channel, or Geostreber made a recording of it. And it was a talk between him and another guy called Imric. I think he has another channel name. Mm-hmm. I recognized his voice recently on Jem Panda's channel. And they talk 2 times about how GPS works. And the second time, it's hilarious. The Multi-Tom has no idea how it works, but is so convinced that he can explain how it works, and he has no idea at all. Well, they talk about other things too, and maybe I send you it once more with a timestamp, and if you find it interesting or amusing,
we can have a look at it again. Yes, indeed.
Because honestly, I don't waste that much time with these topics, but I have to do some work, and I do some works also here building in the house where I live, and that's my brain has not enough foot during these times, and then I hear these things and McToon and the other one I mentioned, Jose J.G. Gonzalez. Have you been on his channel? Or?
I have seen the Gonzalez one. He's also pretty stupid, I guess. Eh? or not?
He has Bob the Science Guy is up there, or Blue Marble Science, you probably know.
Yeah.
And he has a lot of good guys that can really explain well, and then some idiots.
Yeah, with whom we... okay, then the Gonzalez is probably somebody else, but there is also a Spanish-sounding guy who has absolutely no understanding of the world around him at all.
Has it been a long time ago since you listened to him?
Yeah, probably. Yeah, if let's say half a year is a long time.
No. It's since 1.5 years he converted from flat Earth back to globe Earth, and I think he really does his shows well. But sometimes it gets boring because the flat earthers who are there have always the same arguments, and it gets really boring. They have really no understanding for this. Okay.
Yeah.
But why did I say this? No idea. Okay, so we have. Let's just see. I could well do another half an hour.
Yeah,
or so
it's good.
If you want.
Yeah.
It's good. Okay. So if you want to bring up another topic, maybe one you think of it yourself.
No, you had.
I have just a question in between, which is not related to what we did before and what we may do now. I think you said you came to Flat Earth initially via a Wolfie's channel and from atheist channels? Or?
Yeah, from the atheist experience.
Okay. So that is another thing we have in common. So I'm always a little bit cautious not to bash Christians or so when I'm not sure what my conversation partner thinks.
Why not?
I don't want to hurt feelings unnecessarily. And MC Toon, for example, is a Christian. That you should know. But okay, I have one thing on my list. If we had it is very short, 2 or 3 sentences. I think some things are a bit stupid when we criticize Christians. For example, this thing that the Bible says pi has a value of 3, only because a pond is described which had a certain circumference and a certain diameter, and the relation between which is 3. I think 2,000 years ago in a book, the people who read this book had no idea how you do fractional numbers. And
right.
Because of that, the Bible says pi has a value of 3 is a
It's a very poor excuse.
Argument,
yeah,
very weak argument, and I would not bring this up.
I would also not do that. I would only probably bring it up as a sort of argument saying, okay, you want to believe that the Bible is true. Pi is around 3, according to your Bible. I can live with that, because if we then go back to our previous discussion about the distance of North Pole to equator, with a pi of 3, you still come up to an equator of 60,000 kilometers. Yeah?
Wonderful argument for those who come from religious motivation for flat Earth. Do you also know this Pastor Stephen Anderson?
Probably not. Maybe I've seen him, but...
This pastor is a somewhat strange guy. He's a strong Bible-oriented, and has some strong convictions because of this. But he clearly says flat earthers are idiots. And I would always like to see, maybe on Steve McRae's channel also, a discussion with this pastor and flat earther motivated by the Bible. This pastor, for example, does not believe in evolution. He's a creationist, and he has some other strange things which are today not any longer politically correct.
Yeah.
For example, that woman must always be at the will of their husband if he wants to sleep with them, and no matter what the wife will.
Probably is in favor of slavery. Yeah.
I'm not quite sure what he thinks about slavery.
Well, if he believes the Bible.
He says, whoever argues with the Bible that the earth is flat is an idiot.
Yeah.
And it would be nice to have this one in a discussion with a biblically motivated flat earther.
Yeah, but I think that he has much bigger problems than the shape of the earth when he is trying to justify his Bible. There is a lady, and I really would have to look her up. Hold on, I have a playlist on my channel, and the lady is Francesca Stravakopoulou or something like that. And no, I think maybe Greek. But what is very interesting about her is that she speaks and can read all the old languages, but also the dialects. And she can see if one part on a papyrus roll is written by the same person or not.
Okay.
Simply by the use of dialect or the time it was written or whatever. And she claims she is a big fan of the Bible because it's such a beautiful book. But when you then ask her, is it true? Then she says, no, nothing is true. And she has studied the Bible. She knows she can really, there are very few people in the world that even now today can read the old original documents. And she can. And she says none of the persons described in the Bible ever existed. Yeah? And and none of the events, of course, never happened. So I think that the problem people have who want to believe in the God of the Bible and who literally want to believe the Bible, I think they're that wrong. That people want to believe in something, okay, I can live with that. And if you do that from a sort of a Christian point of view, then you can anyway look more to the figure of Christ than to the Old Testament. But the Old Testament, basically the Jews already abandoned the literal belief of the Old Testament. So how come that Muslims and evangelistic Christians think they know better than the Jews whose book it is? Yeah? And from a more physical point of view, if you really would like to believe in the 7 day of creation, there's one thing that must be true always, is that the day God started, let's say, his creation, all the physical laws that we have today were there at that moment as well. And that means that he created trees without having a sun. So the temperature must have been below 250 Kelvin. Below minus 250 Celsius, near 0 or 10 Kelvin.
Zero, yes.
So everything died the moment he created it. It's all impossible. This
is not a problem for believers. They say then at that time the rules were different or so. I have given this up, and I it depends on how much you want to talk about it. I can talk all the time about.
Well, one of the things we could do, Michael, is the example of the vacuum. Das Vakuum.
A vacuum, okay.
Yeah.
Okay, vacuum. Okay, so maybe there cannot be a vacuum near to close to a pressurized system.
Right. Yeah.
Okay. I have one thing maybe in advance, and then can you talk about it? I think it's Bob the Science Guy who said it is a big difference between atmospheric pressure and gas and pressurized pressure in a container, which he calls gas pressure. And if you go, I think, to Wikipedia or so, or some physics site, there are actually 2 different entries for this, atmospheric pressure and gas pressure. And I think if we agree on that, we typically address those who sit on the fence. This is not that good an argument because, of course, you can say atmosphere is also gas and it has pressure, and why is it different atmospheric pressure and gas pressure? And it sounds a little bit like a cop out if we make a big difference between this. And if I put myself into the shoes of a flat earther, I can even come up with a thought experiment to show you that there's really no difference, because just imagine you build a very, very high tube that is open on the top and put it in the atmosphere vertically. And of course, inside the tube would be the same pressure like outside. You have a pressure gradient in it.
Yeah.
And if you put a cap on the tube now, or if you do hard barriers between any section within the tube, also nothing changes. And you, at the one thing, you have a pressure. If it is high enough, you have a pressure gradient. So the real difference is that the atmospheric pressure is typically measured in an extremely high container, which, if that container would keep some gas, would also have to show a pressure gradient. And the real difference is that the one pressure, the gas pressure in containers, which we talk about, is really very high. And the atmospheric pressure really drops to zero about at the Kármán line or so. But you know that recently, I think 3, 4, 5 months ago, someone said even the moon is in Earth's atmosphere because there are small amounts of atoms of our atmosphere also close to the moon.
Yeah.
And of course, I understand the difference, but I think to say up front, there's a big difference between atmospheric pressure and gas pressure. This can be viewed as a cop-out from someone who is not quite convinced.
Right. I agree totally. You only need a container that is like 20 meters high, and you would be able, with what we now today have in accuracy of measuring devices that can measure pressure. So if I would fill a container which is horizontal with normal 1 atmosphere air, I close it up, I put it upright, you will see a difference in... Yeah.
Yeah, it's a little bit higher pressure because it's more volume in it.
No, if I do not put pressure in it, I just have it open and then I close it, so I'm not pressurizing it, then it will have the 1 atmosphere of...
It will have the same gradient that we would get in the atmosphere,
yeah.
But in principle, if we say take 100 meter or 1,000 meter long pipe and put it horizontally first and then close both ends and hold it up vertically,
yeah.
Then there is a little bit more inside it as it would be if we had filled it when it was already vertical.
Yeah, probably, yeah, indeed, because you have some more air in there. Now, if you have a smaller containers like 1, 10, 20 cubic meters, you can apply indeed the gas laws, which do not apply on the atmospheric pressure. That's one of the things people then confuse. But I always say the following. How come we think that there is no pressure in space? That is because when we go up, Sluis Parkane, I believe, did it with a car. He drove up in a mountain in Germany, and he showed that they...
Yes, and the air balloon, yes.
Yeah, right. So he proved that the higher you go, the lesser the atmospheric pressure is. And we know that when you are in the Andes at 5 kilometers high, you already are about half an atmosphere pressure. In other words, you already have half vacuum. And when you're in a plane at, let's say, 12 kilometers, you are already in 90% vacuum. If the Earth is flat, the same applies.
Yep.
So they say you can't have a vacuum or a vacuum in a dome, then they are totally wrong. 99% of the volume of the dome is vacuum.
Yeah.
Yeah, that is the biggest mistake they make. If the Earth is flat and we are surrounded by a dome, if you go up 10, 20 kilometers, you already have 50% vacuum if you go higher. And once you are at 100 kilometers high, then you are basically 99% vacuum. And then you're still, I don't know how far away from the top of the dome, because the sun apparently goes at 5,000 kilometers high.
Yeah.
So the sun and the moon move in the dome in absolute vacuum. Now, that is, in their idea, not possible. Therefore, the dome is not possible.
Okay, I can play the flat earther here because I have listened to enough of José's show. Maybe you switch José with Brother Sanchez. There's another flat earther. Then maybe listen to José's shows one time. He has both sides and also pop the science guys on there. But can you say what the flat earther will say? But to get pressure in the first place, you need a container. Yeah. Is the first thing they say. And then, of course, they deny gravity, and then probably quantum arrays, and then who always asks, do you mean Newtonian gravity or Einsteinian gravity? And they are very good to derail the conversation to completely other corners. And I tried once with one of them in comments to a video to get him to the point where he agrees on if I have a bottle of pressurized air, that it weighs more when air is inside that bottle as compared to the bottle is empty, because I wanted to make an argument that air has weight. Yeah. And if air has weight, the next step would be, now where does this weight go of the column of air that is above us? Yeah. And he was not to get to the point to agree on that gas in a bottle has weight. No, man, no. I did not get into this point. Mm-hmm. The conversation stopped at some point, and he said, but to have pressure, as you see it with a bottle of pressurized air, you need a container to have pressure, and so it was. And they think the atmosphere is something different. On the other hand, there is the illogical point that it needs to have a firmament above it. Which,
as a dome, is a construction that can't hold itself.
There's no known material, but God will fix it. God will have such materials. It is basically what they have is, if you play a very simple kids card game with them, where you have cards which has numbers on this, and everyone shows a card, and the one who has the higher number on his card wins and gets to this. And as if you have played this as a kid, you know that it may last a long time, but it won all the cards, of course. But if you allow to come up with numbers you write on fresh cards, the Christians always come up at the end and write an unendlich,
infinity.
Sign, it's the infinity sign on their card, and they hear with this, I trumped you all, no matter what you do. Yeah. That is, they pull the God card, and this explains everything that is there. Yeah. So,
but I always draw the infinity sign +1.
yeah. Or infinity squared. Or, Okay. Okay, but they will not. Probably they will not agree that the atmosphere is the same as when you have gas in a container, and they say you need to have pressure in the first place. And of course, they cannot. If they agree that heavy things fall, I think you have made 10 or 20% of the way you have to make. Mm-hmm. You need at first. It need not be gravity. Empty, heavy things fall down. Yeah, you need. This is the first thing you need to get them. And if you can get them to the pressure gradient, and there is some question. There is one flat earther on José's show who gives the impression to make very reasonable arguments, but last and finally he again comes from the Bible or so. But he has put up an interesting question. Basically, the atmosphere gets thinner and thinner. So the Kármán line is an arbitrary construct. Yeah, We can agree on this. So over the Kármán line, you still have atmosphere, but it's thinner and thinner. And now he asks, when does the atmosphere stop to move with Earth? Yeah, it's clear. Yeah. Directly upon the surface, it moves with Earth. If you leave moderate wind out of the equation, the winds move now 1,000 kilometers per hour, so it clearly moves with Earth. 100 meters up also, 1 kilometer up also. So if the atmosphere never ends, at which point does the atoms or the molecules in the atmosphere not any longer move with Earth?
Yeah.
That is actually an interesting question, and just give me your ideas on this, and maybe when we then come to an end, I will tell you a video idea I have to make to explain this, that this question makes no sense beyond a certain point. But just at first, let me know what you tell him.
I think what is happening there is the following, that we know that around 3,000 kilometers, is that the, no? And at what height do they think the temperature is around 3,000 Kelvin?
In the thermosphere, I don't know which height it is, okay?
But at that point, so basically you could be there and you freeze to death, although what is there as a remainder of the atmosphere is moving at speeds as atoms would do in a temperature of 3,000 Kelvin.
Okay.
So what happens if it doesn't bump into another atom as air does at ground level? It will escape into space. It will not follow.
I would have to look this up. I'm not sure. Is the speed of the atoms actually beyond escape speed?
Yeah, but it doesn't. Yeah, but when it's that far away, I don't think it needs the escape speed of the Earth anymore, because the escape speed of the Earth, there are two definitions, but one, and that's the most important one, often done wrong, is the speed you need to shoot a gun or a bullet or a rocket as the starting speed to leave orbit.
Yeah, they have one speed to leave Earth orbit, and the next speed to leave the orbit around the Sun.
Right.
Two different speeds.
Yes, but
escape velocities, two different escape velocities.
But normally the escape velocity is the speed I give you when you are on the ground as a starting speed. And that's totally different than when you're already 3,000 kilometers up.
I don't actually think so.
Yes.
It may be less, but maybe my feeling is wrong on this. It is again squared the energy.
But
it's half an Earth diameter out.
Yeah.
So we are square root. It is 2. It's a little bit less than half. I'm not sure. I would have to calculate it.
You could try. What I think that is happening there is that because the effect of gravity must be less, else we would not have such a high atmosphere like 12, because then everything would be pulled down. Apparently, the movement of atoms is good enough to have at 10 kilometers still air that is not falling down under the push of gravity. On single molecules, the bumping against each other keeps them up.
But couldn't we would really have to do a calculation?
Yeah.
But just as we think about it, couldn't it be that thus such atoms which do not bump into anything still get caught by?
Yeah. A part will still be caught, and a part will start to escape.
But it can only depend on the velocity they have. It can depend on nothing else.
Maybe that things like solar wind or other things influence behavior as well.
Artificially and leave just one factor.
Yeah, but
then you could also say they get bumped out by solar winds if they are.
Right, there's all kinds of stuff happening, but we know that it's like a couple of million tons of air per year that we lose of our atmosphere.
Yes. But just something only, what I have stored in my brain is that mostly helium atoms escape from atmosphere. It's mostly that we lose helium more than any other.
But there won't be millions of tons. I once found on Wiki, you can find it. It talks about tons of gas, at least, that we lose in the atmosphere. Now the question is, where does it start? I think that is also some sort of gradient. and certain atoms will, for whatever reason, be bumped directly out, and others will be bumped just to a somewhat higher level, where they remain for some time, and then bumped up higher again, and then at one point they come in the very thin part, but they are heated, they are moving at much higher speeds, because they say the temperature is 3000 Celsius up there.
Yeah, okay.
And the only thing there that defines, I think, the temperature is the movement of the gas molecules.
Yes, the temperature is defined as, if I remember it right, as the average energy the particle has. If heavier particles can move slower to have the same temperature as lighter particles.
Okay. No.
It's the average energy of the average particle. But let's strip it down a little bit more and say we only have Earth.
Yeah.
Short experiment. Only have Earth. We only have gravity. We have no sun and nothing else. So now the Earth turns, and close to Earth, atmosphere turns with it.
Yeah.
I'm not quite convinced that we really lose a lot. I know that we lose atmosphere, but it can also be because at some point they get pulled by the moon or something. Yeah. They get to get pulled by the moon. But when you take one simple atom or molecule and leave it alone, it's still under the influence of gravity. And if it doesn't hit anything, it will at some point lose has the same potential energy that it before had as kinetic energy, and from that point on it will turn back to Earth and collect kinetic energy from its potential energy. That is what I think, and
that is conservation of energy.
Yeah, and there is nothing else. There is no friction.
Right.
Friction basically doesn't exist in gas. It's an exchange which obeys the law of conservation of momentum and conservation of energy. And as long as these two laws, I don't think that bumping two molecules together, maybe it can change the path of an electron around it, and some energy is irradiated as electromagnetic wave, but then it must even come faster back to Earth if this could happen. And on the other hand, I just was thinking about how in the thermosphere the molecules can receive energy by radiation. I think the only thing that can happen is that an electron jumps higher and they radiate it again.
But they are totally exposed to the sun to receive.
But how can a single molecule receive energy? It has potential energy in a gravitational field. It has kinetic energy.
Yeah, and it gets hit with infrared.
Yeah,
and therefore.
It can absorb the infrared and then re-emit it in an arbitrary direction.
Yeah, I guess so. Huh? Or it just picks it up as and turns it into a higher speed at which it moves.
But only via an intermediate of a change of the electron path, I think. Or can it?
Yeah, probably.
Can it absorb the electromagnetic?
How does your skin get warmer when it is hit by the sun?
Because as it is not gas, there can be vibration in the structure that holds the molecules together. So probably I could imagine if we have molecules there that can have a certain freedom to vibrate.
Yeah, and they start vibrating heavier.
Please?
But what makes them vibrate heavier, faster? This energy that it has to pick up somewhere. But we're deviating now, because the question was, why doesn't the atmosphere start to slow down, eh?
Yeah, when does it not follow the rotation of the Earth anymore?
And the question, I think that in general, if we take out all the other mechanisms, that it will not move slower, because and that's basically the whole thing also with the atmosphere itself. The mistake everybody makes is they say, the Earth should be spinning. And why does the air spin as well? But they forget that when the Earth was formed, everything, the whole mixture of gases was spinning. And from that spinning, it started to, cool down into the heavier part being Earth, the waters and the air. But it was already rotating in this giant ball of materials that formed Earth. So that is the starting point. And then you have basically no friction to the outside. The mistake also made by many flat earthers, they come up with a demo and they say, look, I have pen and I rotate the soup and it will move slower at the outside. Yeah, because you have your friction on the outside, but we don't have friction on the outside. We have zero friction on the outside, being the vacuum of space. So I don't think it slows down really.
That's exactly the point. They think everything should have friction somewhere. That's a misunderstanding. I find in many of their positions, I find how I thought as a child. As a child, I could not understand what air is because you can't see air and so But I think your argument that the elements are generated when the Earth was formed. This can only be true for the atoms that replace the atoms.
No, I don't say elements created. They were already there, of course. In the soup, everything was there.
But my explanation usually is that friction on the Earth's surface would swirl the atmosphere around with Earth.
And if you would start, that is the second thing I sometimes say. Suppose the Earth would be turning and the air would stand still. Then we would have these winds of 1,600 kilometers per hour on the equator. And then I say, look at the Earth, and you have the Andes mountains, and then you have the Rocky Mountains, and you could see that as a big scoop from the North Pole to the South Pole that is pushing air along each time, and it slowly will bring, like a spoon that is turning in water, will slowly bring all the water up to speed with the spoon.
And the essential thing is you have no friction at all
on the outside.
At base, and therefore sometime everything must turn. And that's a little bit the analogy I would like to bring up for flat earthers who need to imagine this if they are reasonable.
This could be an explanation, but the real thing, as far as I understand, is because the whole soup from which the Earth was formed was already one rotating bunch of atoms, and therefore once rotating, it never stopped rotating.
Okay, I think we can join your thought model and mine together, because my thought model would be to transfer this all in a thought experiment, but in only 2 dimensions. And if you have, in principle, infinite plane, on which there are, say, robots or people or billiard balls or so. I prefer not to take billiard balls because people then think of friction again. Say, let's small ants or something, or small tiny robots. And these robots are programmed to always walk in the same direction. Until they bump into one other of them, and then they keep up the laws of conservation of momentum and of energy, and each of one goes in a different direction. And so they swirl around, and if you put a wall around them, they would bounce at the wall, and you get the idea what a gas is, but into 2 dimensions. And then imagine you take out the outer barrier. What happens, of course, at some point, one of these robots would bump into one and never met anyone else and dissipate far away. And you get always less. So now we modify this a little bit. And I first thought, if I should do this in the way that typically the bending of space-time is demonstrated, that we say that in the middle it's a little bit deeper and they have a slight tendency to return back to the middle of this plane, but I switched to something different. because this is so often misunderstood, this bending of space-time, which we cannot really imagine in our brain.
Yeah.
Our brains are not made for this. And therefore I turned it this way, that in the middle of this infinite plane, there is a tiny light. And the robots, like flies, have a small tendency to walk a little bit in order to turn a little bit in the direction of this light if they walk away from it. So that they last and finally they have a tendency to come a little bit together in the middle.
Mm-hmm.
And this tendency to go to the light in the middle, of course, is gravity. It's a replacement for gravity. And now, if you put in the middle a cogwheel, which something turning with a substantially rough surface, so that if these robots go too far in the middle and touch this cogwheel, they get accelerated a little bit in the direction in which it turns.
Mm-hmm.
And again, when they are then a bit more far from this wheel, they bump into each other. Some bump farther out, but they also have a tendency to come back. If they not for a long time, they bump into one other who throws them further out.
Yeah.
So now the question is, when do they stop to move in the same direction which this cogwheel runs? And you can say this happens then if they bump fewer and fewer times and are basically alone. And then they go, due to their conservation of momentum, they go straight out with the last tangential speed that they have. So some little bit like the Coriolis effect, you can see. But as there simply isn't anything there in which they could bump, they turn back. Of course, and then you can put in the other planets in this flat model. There are occasionally other lines in this infinite plane, other gravity wells in our speed. And if this other gravity well gets brighter to them, as the one they came from, they switch over to this.
Yeah.
And this would be, for me, the 2D explanation of this. When does the atmosphere stop to rotate with Earth?
I suddenly have it, I think.
Yeah.
Let's assume with something that is at 5 kilometers high. So it is moving along with the Earth at a speed just a little bit more than the 1600 so many kilometers per hour, because the radius is a little bit higher, bigger, 5 kilometers. So in order to make a full turn, it doesn't do 40,000 kilometers, but 40,000 plus kilometers. So it's a bit faster.
Yeah.
If I now, for whatever reason, with my speed in that direction, get a big push to, let's say, 20 kilometers, and I'm still moving with 1700 kilometers to the east, I am not being able to catch up with my reference point on Earth, because I have to make a bigger circle.
Yeah.
And that makes me lag behind.
Yeah.
So I think it's a gradient, but there is some lagging behind the more you get up, simply because the molecules moving all at the same initial speed toward east have to go a bigger distance.
If there are too little of them, they don't get the extra tangential speed at first.
Yeah.
And
they start lagging behind. Yeah.
Lagging behind. And probably that's the fusion of the two models.
It's a fusion, and it starts already when you're 10 meters high, basically. Although it is a not measurable thing, but
because in my analogy, it is so crowded there that you are always swept with the crowd.
Yeah. And the reason why I suddenly remember this is I'm making a PDF where I try to use like 10 points for every 1 point that is in the 200 reasons why this is not a globe. So I'm putting links to videos, formulas, Wikipedia, quotes, whatever. And I was working on the example where they say that if you shoot a bullet up, it should never on a globe. It should not come back into a cannon, and that people have done tests, and it was. And that people have done tests, and it was falling next to the cannon. And I was trying to find how can that be, because the bullet is also turning. Even when it leaves the cannon, it has its original rotation speed. But when it goes up like 5 kilometers and then falls back, while it was at 5 kilometers height, it was lagging behind the gun.
Yeah.
Yeah, it was still moving with the same speed toward east.
The speed.
Yeah.
Yeah.
But it had to do a greater circle, and that is why it might fall just next to the gun. But
it's the Coriolis effect.
Yeah, sort of. Yeah. Yeah. Hey.
Except for the North Pole, of course, so there it would fall back in the cannon.
Yeah. And yeah, but that's not. That's only rotating in itself, huh? Yeah. Michael.
No. The rotational momentum it would keep.
Yeah. Okay, but it's rotating around its own. If you shoot from the North Pole straight up, huh?
Yeah, it has a rotational. The bullet has a rotational momentum in the cannon, and this one it will keep.
Yeah. Correct.
Okay.
Hey, I have more than 1.5 hours after you have seen it and you're okay with it. Only then I will publish.
Okay, so.
Don't know much about history. Don't know much biology. Don't know much about a science book. Don't know much about the French I took.